Hi, ladies and gentlemen. So today is, I shouldn't tell you the date, but it's September 10th, and it's the evening, and I'm in New York City, and I want to talk about Chapter 7, which is methods of integration, and I'm going to do Section 7.1 today, and we'll probably continue with some problems tomorrow from Section 7.1. 7.1 is called integration by parts. So let me get started with that. Okay, okay, section 7.1. I'm going to be doing this on an iPad today. Okay, so let's start off with reminding you about the product rule of differentiation. It says that if you have functions u of x and v of x, and you want to differentiate with respect to x, the product u times v, it's du dx times v plus u times dv dx. Now, this is the standard way to write it, but if we can get rid of the dx's on both sides and write it in so-called differential form. Which means that d of u times v is equal to, I'll reverse the order of the first two terms, v du plus u dv. Okay. All right. So let's integrate both sides of this. If we integrate the left-hand side, we'll get that the antiderivative of the derivative is u times v, and the right side becomes the integral of v du plus the integral of u dv. And now we can bring two of the terms over, one of the terms on the right side over to the left. We could write the integral of u dv is equal to the integral, oops, not the integral, but u times v minus the integral of v du. And this is called the integration by parts formula. Okay, so how do we use this? Well, it's best to just do lots of examples, and we'll see how it works. So here's example 1. Consider the integral of x e to the x dx. So the idea is we have to figure out what u is and what dv is, because the left side of the formula has a u and a dv. So I'm going to let u be x, and then dv is e to the x dx. And then we have to figure out what, using the right side, let me first make this a little neater. This is going to be a du here. So we need to have what v is. Well, dv is e to the x dx, which means that v is the antiderivative of e to the x. So v is going to be e to the x plus a constant, but you can take any antiderivative. That's going to be fine. And then we also need to know what du is, because that's on the right side of the formula. Du is derivative of x dx, which is 1 dx. Okay, so if we apply the integration by parts formula as shown, we get that it's u times v. So u times v is x e to the x minus v, the integral of v du. V is e to the x, and du is dx. And now the rest of it is easy, because the integral of e to the x is e to the x plus c. So we've just computed our first integration by parts, and that's what you get. So this was not very difficult, this problem. Okay, so let's do another problem. Okay, the next problem I would like to do is the integral of ln of x dx. This is not something you can do by ordinary substitution. We have to use, it turns out integration by parts is the only way I know how to do this. So now we have to figure out what u is, we have to figure out what dv is. Now, whatever u is, dv is the rest of it. So there's not much of a choice in this case. We can let u be ln of x, and then dv is what's left over, that's dx. And then du is 1 over x dx. And v is the antiderivative of dx, which is x. And so this becomes u times v, which is x ln of x, minus v du. So that's the integral of v du. Well, v is x and du is 1 over x dx. So you're going to get, they cancel x and 1 over x. You just get the integral of dx. And this is x ln of x minus x plus c. Don't forget the plus c. You lose a point on my exams if you don't have a plus c. Okay, so that's a simple problem. Let's do another example. This is a little harder. It's the integral of x e to the x cosine of x dx. Okay, so how are we going to do that? Well, there are two possible choices. We could let u be e to the x, or we could let u be cosine of x, and then dv is what's left over. So let's try u equals e to the x. Let's see what happens. Then du is e to the x dx, and dv is what's left over, and that's going to be cosine of x dx. And so v is the integral of cosine x, the antiderivative of cosine x, which is sine x. Okay, so what do you get? You're going to get uv, which is e to the x sine x, minus the integral of e to the x times sine x dx, because that's v du. Okay, now we're stuck, because now we have a new integral to solve that doesn't look any easier, but we can try to do, here's the trick in this case. This is one of those things which you can do a trick on. The integral of e to the x times sine x, we can just do it the same way we tried to do the original case. That is, we're going to let u, and you know what? It makes sense to give the variables a new name. So I'm going to call I'm going to use big U and big V. So big U is e to the x, and big V is sine x dx, and d big U is e to the x, and big V is negative cosine of x. So this e to the x sine x integral is negative e to the x times cosine of x, that's u times v, minus the integral of minus cosine of x e to the x dx. Or we can rewrite it, and I'll rewrite it here as minus e to the x cosine of x plus the integral of e to the x cosine of x dx. Okay, so we've just computed the integral that appears at the beginning of example 3, the integral of e to the x sine x dx, and this is what you got. So what I'm going to do is I'm going to substitute. It doesn't look like we got anywhere, you'll see, but we did, because if we substitute in to the right-hand side where we just computed, we get the integral of e to the x cosine of x dx equals e to the x sine x minus this integral. But what is that integral? That's subtracting off the expression I just computed, and that's going to be double negative is positive, so it's plus e to the x cosine of x minus the integral of e to the x cosine of x dx. Okay, now here's the trick. There's a term on the right that equals the full left side. So we could add to the left side the term on the right. So I'm going to get twice the integral of e to the x cosine of x dx. equals e to the x sine x plus e to the x cosine of x. And then we can divide by 2, and then we'll get the integral of e to the x cosine of x dx equals 1/2. We should probably put a plus c in over here. E to the x sine x plus e to the x cosine of x. Let's call the c prime because I'm going to divide c prime over 2 to make c. So this is the final answer to the problem. Oh, there's another 1/2 over here. So, so that's the answer in this case. So that's that problem. That was a little harder. Okay. Okay. So now the other part of this section deals with definite integrals by parts. Okay, so, and really all it is the integral from a to b of u dv. We just stick in limits of integration is equal to u times v evaluated from a to b minus the integral from a to b of v du. Okay, so here's an example. We can do it, a simple example, the integral from 1 to 2 of x ln of x dx. Okay, there are two possibilities for choosing u. One is going to give us a problem, I think, and the other won't, right? Now, here's attempt number 1. We can let u be x, and then du is dx, and then dv is ln of x dx. Now we computed what the antiderivative of ln of x is, and what did we get? We got the integral, the antiderivative is x ln of x minus x. Okay, and then so if we write down the integration by parts formula for that, we'll see that you get u times v, which is x squared ln of x minus x squared. I multiply x by what the expression for v is, and then I have to subtract off the integral of x ln of x, and this is, by the way, from 1 to 2, and then the integral from 1 to 2 of x ln of x minus x dx. Oh, I think this is going to work out because we can, let me go down here. This is equal to, okay, so if we stick in a 2, we're going to get, I'm going to evaluate now, we're going to get 4 ln of 2 minus 4. And if we stick in a 1, we're going to get x squared ln of x. Ln of 1 is 0, and then minus 1. Okay, so that's the first term. And then the second term, I'm going to break it up into 2 separate integrals. One is the integral from 1 to 2 of x ln of x dx. And the other is double negative is a positive. It's the integral from 1 to 2 of x dx. And now this can be done. First of all, this is the right-hand side, so we can bring over this extra term over to the left side to get twice the integral from 1 to 2 x ln of x dx is equal to, well, what do you got? You got 4 ln of 2 minus 4 plus 1, so it's 4 ln of 2 plus, it looks like, plus, no, minus what? Minus 4 plus 1 is minus 3. And then the remaining term is the integral of from 1 to 2 of x dx. That's x squared over 2 from 1 to 2. And that's 4 ln of 2 minus 3 plus 2 squared over 2 is 2 minus a half. So what do you get? You get 4 ln of 2 minus 3 plus 2 minus 1. Looks like minus 3 halves if I did this correctly. So that should be That should be the answer in this case. But I'm going to, so it looks like, I think I got it right. Let's see. 2 minus a half is oh, it's 3 halves. Minus 1. It looks like 3 halves. Okay, let's see what, I think this is right, unless, but that's twice it, so I have to divide by 2, because there's this extra 2 here. And this, it turned out to be much more complicated than I wanted it to be. It's going to be given by 2 ln of 2 minus 3/4. Okay, so that's the answer you get by doing it this way. I hated this approach. I don't like it. So let me try it another way. Okay, so let's try it another way. Okay, so let me clear the board. Okay, so alternative approach, which is much easier. This shows you that it matters what you let u equal. So the only so we're doing the integral of x ln of x dx from 1 to 2. And now I'm going to let u be ln of x. That's my plan. And then du is x dx. And let's see if it's easier to do, you can do it this way, and if it's easier to do it this way. So du is 1 over x dx, and v is dv. V is x squared over 2. So if we do the integration by parts formula, you get u times v. That's x squared over 2 ln of x from 1 to 2 minus the integral of v du, and x squared over 2 times 1 over x times dx is what you get in the integrand. And now I'm going to bring this down over here, and it's going to be equal to, so if we stick in 2, we get 2 squared over 2, which is 4 over 2, which is 2 ln of 2. And then ln of 1 is 0, so that doesn't affect anything. And we're integrating from 1 to 2, so it's the integral from 1 to 2 of x over 2 dx. So we get 2 ln of 2 minus x squared over 4 from 1 to 2. So that's 2 ln of 2 minus 2 squared over 4 is 1 minus 1/4. So it looks like, what do you get? You get 2 ln of 2 minus 3/4 again. So that's this correct answer. Okay, so the next thing I want to do is I'm going to do one more problem today, and then we'll continue next time with some more examples that are more difficult. So let's clear the screen. Okay, so the next example I'd like to do is not, this is not a definite interval, it's just a regular antiderivative. Okay, so now I want to do this using integration by parts. This is the arc or cosine or the inverse cosine function. So, so we're going to let u be the inverse cosine of x. Then what is du? Well, sometimes you don't remember the answer here. I'll tell you what it is, and I'll tell you how we got it. This is something from Calc 1. This is what it is. Minus 1 over the square root of 1 minus x squared. I'm going to show you how to do that calculation here. What does it mean for u to be arc cosine of x? It means that cosine of u is x. So I can take the derivative of both sides. And if I take the derivative of both sides, I get negative sine of u du dx equals 1. I've implicitly differentiated. So we get du dx equals negative 1 over sine u. And so we have to figure out what sine u is. Okay, so what is sine u? Well, cosine of u is x. So if I do a little right triangle, we put x here and 1 is the hypotenuse. Cosine of u is 1, and then this side is the square root of 1 minus x squared. And so we see that this is negative 1 over the square root of 1 minus x squared, because sine of u is the square root of 1 minus x squared divided by 1. Okay, so that's how you do figure out what du is. dv is dx, so v is x. So now we can do the integration by parts formula. I'll do it down here. It's u times v, that's x arc cosine of x, minus the integral of v du, so that's negative x over the square root of 1 minus x squared dx, or if you like, x arc cosine of x plus the integral of x dx over the square root of 1 minus x squared. So that's, I've just gotten rid of the two minus signs and turned them into a plus sign. Okay, we're left with one thing to do here. We have to figure out this integral. So I'm going to do this integral over here, the integral of x dx over the square root of 1 minus x squared. How do we do that? So I'm going to let u be equal to 1 minus x squared. Then du is negative 2x dx. We don't have a negative 2x dx. We have an x dx in the integrand. So I'm going to divide both sides by minus 2. So negative 1/2 du is x dx. Okay, so then we can substitute now. We get the integral of negative 1/2 du, that's x dx, over the square root of u. Or if you like, bring it down here. It's minus 1/2 the integral of u to the minus 1/2 du. And if you do the antiderivative, you'll get that this is negative u to the 1/2 plus c. So that's, and u is the square root of 1 minus x squared. So I'm sorry, u is, yes, so what is u? What was u? 1 minus x squared. So it's u to the 1/2 is the square root of 1 minus x squared plus c. So finally, going back, we're going to get x arc cosine x minus the square root of 1 minus x squared plus some constant. Okay, so that's the story. That's the last example I wanted to do today.